EPS2. Part 7. Filter clog. Filter resistance relates to temperature and biological activity. Slow sand filter plant in Ueda, and the indicator of filter resistance that is called an HL. Please watch this 4 minutes YouTube video. You can image my field. Actual head loss is not an index of filter resistance as it is. Actual head loss is proportional to flow rate. Apparent head loss HL equals this value is not an index of filtration resistance as it is. Calculate HL when filtered at standard filtration rate. Equals we call normalized head loss. That is an HL. Clog indicator. Head loss filter resistance is proportional to flow rate. NHL at normal velocity rate can be calculated by the actual head loss and the observed actual velocity rate. You can calculate these formula. My main field is Sumya water purification plant. Original water source was subsurface water from river Chikuma. At that time, this water was pumped up to the plant. In 1953, new intake of surface water. Sugadera Reservoir was constructed in 1968. After that, tap water turned bad taste. At that time, algicide was used to kill algae in filter pond. At Sumya water purification plant, prechlorination and copper sulfate were added as algicides to suppress algal growth. Then, the filters clogged easily. There was also a problem with the smelly tap water. In rapid sand filter, it was common knowledge to add chemicals that biological communities dislike. Chemicals were also added during slow filtration in biological treatment. At that time in summer of 1979, the resistance of the filter quickly increased even small load of suspended solid. When stopped the algicide, this filter did not clog in 1990. In February and winter, filter clogged with small amount of suspended solid due to weak biological activity. In my city, addition of algicide was stopped. However, addition of coagulant is used to reduce the load of turbid matter. Algae grow even small turbid water. When small amount of turbid matter flew to the plant, they added small amount of coagulant in raw water. Water became clear in filter pond, but algal mat was covered with white powder. At the Sumya water purification plant, even when turbid water came, the turbidity of the inflow water to the filter was reduced to below 10 degrees due to the sedimentation basin alone. I think that Japan is mountainous country, settling tanks are sufficient and flocculants are not necessary. Major portion of turbid matter easily set in settling basin. Filtration resistance is related to water temperature, water viscosity and biological activity. During the coldest months, the water surface of the filtration pond freezes. Biological activity is low during the coldest months. And the viscosity of water is high, so resistance increases. From May to November, when algae begins to grow in the filtration pond, the resistance does not increase. When algae began to grow, resistance did not increase even when turbidity entered the filtration pond. If biological activity is good, filter resistance will not increase even if mountain river water becomes cloudy. Water depth is the key. I advise to this plant that in order to activate the biological activity, I advise to make shallow water depth with larger size of sand. I think by my experiments that sand size is not important. The water surface of this filter pond does not freeze even in winter. The resistance did not increase even in winter. This means filter clog related to biological activity.